So in this particular unit especially, you're going to have probably just about daily quizzes, daily homework quizzes.
So tomorrow we have quiz?
Yep. If you take a look at the homework sheet there, you'll see that we're spending about 2 days on every section. So we're going to start off with the system of equations, and we're going to start off with a 2x2 equation. All right, so let's take a look with x plus 2y is equal to 2 and x minus 2y is equal to 6. So my first question to you is, for negative 1 a solution to this system of equations? So in order for negative 1 to be a solution to the system of equations, it has to be true for both equations. So when x is equal to 4 and y is equal to negative 1, does it make equation 1 a true statement? So 4 plus 2 times negative 1, is that equal to 2? So that's equation 1 there. So 4 minus 2, so 4 minus 2 equals 2, 2 equals 2, so that's true. So equation 1, the ordered pair 4, negative 1, is a solution. But in order for this 4, negative 1 to be a solution for the entire system, it has to be true for both equations. So now we plug it into equation 2. So you have x minus 2y, x is 4, so 4 minus 2 times negative 1 is equal 6. Negative 2 times negative 1 is a positive 2. 4 plus 2 is equal 6. 6 equals 6. So that's a true statement also. So 4, negative 1 is a solution to the system of equations. In order for it to be a solution, it has to be true for both. Or in later problems, all 3 or all 4. Because we're going to quickly expand this system of equations 2 by 2, 2 equations, 2 unknowns, into a 3 by 3, 3 equations, 3 unknowns, etc. What do you guys remember about solving systems of equations? From Algebra 1 and Algebra 2. What do you guys remember about solving a system? What were some strategies that you could use to solve a system? So you said solve for one of them and plug it into the other one. So kind of, but what exactly does that mean? When you say solve for one of them, what are you solving for? Okay, so the substitution method. So if you have 2 equations and you solve one of them for one of the variables, substitute that into the other equation, then yes, you can follow through. So that's the substitution method. Any other methods for solving a system of equations? There's actually 2 more. Come on, some of you guys took the SAT not that too long ago, and
Did you add the equations together?
well, so the elimination method. So we're trying to eliminate a variable. So if we take a look at the one that we had up above, so x plus 2y is equal to 2, x minus 2y is equal to 6. If we simply added these two linear equations, you get x plus x is 2x, 2y minus 2y is 0, and 2 plus 6 is 8. Now if we divide both sides by 2, you end up with x equals 4. Now, what are you going to do with that 4? Which one? Either one. So now that we know x is 4, we can substitute this 4 into either one of these equations to solve for y. If we substitute it into equation 1, x is 4, you're going to get 4 plus 2y is equal to 2. Subtract 4. 2y is negative 2, and divide by 2, and you're going to get y equals negative 1. So the solution to this linear system is 4, negative 1, which is what they gave us in the beginning anyway. Okay, so the substitution method and the elimination method are methods that we're going to use. Oh, the third one, graph. If we graphed both of these equations, where they intersect, where those two graphs meet, that is the solution. That's where graph 1 equals graph 2. That would be the solution. If we were to graph these two equations, you would see that they would intersect at 4, negative 1. Okay? Do you believe me? You should always just believe anything you hear. So let's take a look at that. Okay, so our graph, first one is x plus 2y is equal to 2. So that's y is equal to, actually let me do this. So menu, graph, relation. So x plus 2y equals 2. And our second one is x minus 2y is equal to 6. X minus 2y equals 6. Okay, so the point where these two graphs intersect is at, let me move that, 1, 2, 3, 4, and negative 1. So that's their point of intersection. Oh, you guys, if you could see that, that would be nice, huh? Why in the world would you let me go on and on and on and not tell me? All right. So these two graphs, these two lines, they intersect at this point. That point is 4, negative 1. So 3 ways. Graphing. Graphing is the least used method because if you get some pretty gnarly linear equations out there that you have to graph, that's going to be difficult. But the system, the substitution, as well as the elimination method, those are the ones that work. So this should be review for you guys. So let's take a look at an example here. Okay, so how about 5x minus 4y? And that's equal to 9. And then x minus 2y, and that's equal to negative 3. Okay. So we're going to take a look at the substitution method. Now, typically, if you have a variable in one or more of the equations that has 1 or negative 1 as a coefficient, substitution method tends to work nicely there. If you look at equation 2, you have x is equal to negative 2y. X minus 2y is equal to negative 3. So here, we're going to solve equation 2 for x. And solving equation 2 for x, you're going to get x is equal to negative 3 plus 2y. So we just added 2y to both sides. So that'll give us a third equation. Now we're going to substitute this new equation into the equation we didn't bother, which is equation 1. So equation 1 now becomes 5 times x, but remember x is equal to negative 3 plus 2y, and that's minus 4y, and that's equal to 9. So we've gone from 2 equations, 2 unknowns, to 1 equation and 1 unknown. 5 times negative 3, negative 15, plus 10y, minus 4y, That's equal to 9. Combining like terms, 10y minus 4y is 6y. That's equal, add 15 to both sides. 15 plus 9 is 24. And divide by 6. Y is equal to 4. Now, at this point, you have 3 equations to choose from in order to solve for x. You have the 2 original equations, 1 and 2, and we have the modified equation that we have there on 3. Which one of those do you think would be the most logical choice to substitute y equals 4 into? Number 3, because we already have the x isolated. So if we use equation 3, now we have x is equal negative 3 plus 2 times 4, and 8 minus 3 is 5, so x is equal 5. So your solution set is 5, 4. So that's the ordered pair where those two graphs intersect. If we were to graph them, and that's the solution set there. Okay. So substitution. Now let's take a look at elimination. Elimination, if they're set up, so your goal with the elimination method is you're trying to add the 2 linear equations and eliminate one of the variables. So you want to go from 2 equations, 2 unknowns, to 1 equation, 1 unknown. Now, in order to do that, you're going to need to have an opposite of the variable you're trying to eliminate. So you have to decide which variable and then find an opposite. So example, 3x plus 2y is equal 48. 9x minus 8y, and that's equal to negative 24. So you have to decide which variable to eliminate. Some cases, you may only have to modify one of the equations. In other cases, you have to modify both. In this case right here, 9 is a multiple of 3, 8 is a multiple of 2. And then you need one to be positive, one to be negative. All right, so ladies and gentlemen, what would you like to eliminate? The x or the y? The y? Okay. If we eliminate the y, then what do we need to multiply equation 1 by?
4.
So we're going to multiply the whole thing times 4. So our new equation 3 becomes 12x plus 8y, and that's equal 48 times 4, which is 190. 48 times 4, 192. So that's our equation 3. Now we can add equation 3 to equation 2. 9x minus 8y equals negative 24. And we've set this up so that we can eliminate one of the variables. 12x plus 9x is 21x. 8y minus 8y is 0. And 192 minus 24, there's 8, 168. Divide both sides by 21. And x is equal to 8. Okay, but we're not done. We only have one part of our solution. What are we going to do with this 8? Okay, which one? Doesn't really matter. The first one, the second one, or the third one. So you have to decide which one seems easier to you. I would probably plug it into the first one just because my coefficients are smaller. So if we use equation 1, then we get 3 times 8, so 3x, plus 2y is equal 48. 24 plus 2y is 48. Subtract 24 and divide by 2. And you're going to get y is equal 12. So our solution is the ordered pair 8, 12.
So is there a particular time when one method would be better than the other?
Some students, they like their favorites. Like a lot of students, they will like the elimination. The substitution one, if you end up doing substitution and you solve for one of the variables and you get fractions, a lot of students like to stay away from that. But we'll take a look at a couple of examples and I'll show you. All right, let's take a look at one more example and I think we can get started on our homework. Okay, one more example. All right. Okay, so here we have 2x equals 7y minus 17. 5y equals 17 minus 3x. Okay. Ladies and gentlemen, what is our solution here? Where do we start? You want to do substitution?
Yeah.
If you solve for x in the first one, you're going to get x is equal 7 over 2y minus 17 over 2. 5y equals 17 minus 3 times 7 over 2y minus 17 over 2. If you solve for y in the second one, y is equal 17 over 5 minus 3 over 5x. All right, so I'll ask you again, which method would you like to use? All right, so this one you will probably use the elimination method. But the first thing we need to do is we need to write it in this standard form here. A times x plus b times y is equal to c. So from equation 1, we're going to subtract 7y, and we end up with 2x minus 7y equals negative 17. For equation 2, when we add 3x to both sides, you're going to get 3x plus 5y equals 17. Now, we have to decide which of the variables that we want to eliminate. Now, you will see that neither one of the variables x or y, nor y, are multiples of each other. So what we have to do there is once we decide which variable to eliminate, we have to find their least common multiple. Okay. So if we eliminate x, what's the least common multiple between 2 and 3? 6. Because 2 is 2, 4, 6, 8, 3 is 3, 6, 9. So 6 is the smallest number that's a multiple of both. So with the we actually have to modify both equations. So with the first equation, we need a 6. We need a 6. And then we also need one of them to be negative and one to be positive so that they eliminate each other. So we know that we're going to be multiplying equation 1 by 3. Okay, so do we want to do negative 3 or positive 3? You guys say negative 3. So equation 2, we're going to be multiplying that one by 2. So our new equations 3 and 4. So 3 becomes negative 3 times 2x is negative 6x. Negative 3 times a negative 7y is a positive 21y. And negative 3 times a negative 17 is a positive 51. Equation 4 becomes 2 times 3x is 6x. 2 times 5y is 10y. And 2 times 17 is 34. Now when we add those two equations, you're going to get 31y is equal to 85. y is equal to 85 over 31. All right, which one of the equations do you want to substitute 85 over 31 into? Because we still need to find x. So which one would we like to substitute 85 over 31 into? And then on your quiz tomorrow, try to figure out what x is. Is there any rule that says that we can't just start all over and now instead of eliminating the x's, let's eliminate the y's? So we can do the elimination method again to find our second one. That might be easier than substituting 85 over 31 in for y in one of these equations. 2x minus 7 times 85 over 31 equals negative 17. Now you got to get either clear the fraction or get a common denominator and work through that process. Or, let's do this. Okay, so the first time we decided to eliminate the x's, our least common multiple was, in fact, 6. So starting again here, with the 2x minus 7y is negative 17, 3x plus 5y is 17. Now we're going to do the other one. So now we're going to eliminate the y's. So what's your least common multiple between 5 and 7? 35. So we're going to have to multiply, and we already have one negative and one positive. So we can just multiply by positive values. So on top, the first equation, we're going to multiply by 5. And the second one, we're going to multiply by 7. So we're going to get 10x minus 35y is equal to 17 times 5. 17 nickels is 85 cents. 7 times 3x is 21x plus 35y. And again, 7 times 17 is 119. Okay, let's add. 10x plus 21x is 31x. Y's are eliminated. 119 minus 85, I believe, that's 34. Divide both sides by 31. And you're going to get x is equal to 34 over 31. Now, if you had done the substitution method, substituting the 85 over 31 back into either of those equations, eventually you might have come up with 34 over 31. But I believe in this case, because of the fractions, this might be a better alternative. So our solution set is 34 over 31 and 85 over 31. So your homework tonight is not necessarily, because sometimes if you simplify them, they will reduce. But no, not necessarily. All right, so the homework is section 7.1, page 818. And you're doing numbers 5 through 29 odd. So again, homework section 7.1, page 818, 5 through 29 odd. And I will go ahead and get you guys a copy of that.